of our practice work from Monday. There we go. So, first thing we have to do is take each and every single one of our inequalities here, our constraints, and get them in slope intercept form. So my first one is 4x plus 2y is less than or equal to 4. And remember, we want to look like y equals mx plus b, slope intercept form. So we're going to keep our 2y over here on the left is less than or equal to. Transpose our 4x, make them a negative 4x. Drop down our positive 4, so plus 4. Now last step to solve for y is to divide everybody here by 2. 2, 2. 2's cancel. Y is less than or equal to, because we divide by a positive, so we do not flip the sign. Negative 4 divided by 2 is negative 2x. 4 divided by 2 is positive 2. So his slope's going to be a negative 2 over 1, because it's always the guy beside your x. And we're going to begin at 0, 2, this guy here by himself with no variable. So now when we go to graph it, we always begin with b. So 0, 2, origin, then up 2. Now my slope tells me go down 2, right 1. So we always run right, down 2, right 1. Now before we make our line, we have to remember this is an inequality. So I have to look at this symbol right here. So it says y is less than or equal to. So it's going to be a solid line. Oh, hopefully you make a better solid line. Solid line. And where it's less than or equal to, we're going to shade everywhere below it. So I'm going to start down here and shade down. There we go. So make sure, get that good and shaded in, and we're set. Second one here, I'll graph it in blue. So we have 2x plus 4y is less than or equal to 4. Once again, we want to look like our slope intercept form, y equals mx plus b. So we keep our 4y on the left. We drop down less than or equal to. Transpose our positive 2x, make him a negative 2x. Drop down our plus 4. Divide everybody here by 4. 4's cancel. Y is still less than or equal to because we didn't divide by negative, so our symbol stays the same. Negative 2 over 4 is a negative 1/2 x. And 4 divided by 4 is 1. So for this one, we have a slope of a negative 1/2. And we're going to begin at 0, 1. There we go. And when we go to graph it, we begin with b. So 0, then up 1. Our slope tells us to go down 1, right 2, down 1, right 2. Remember, we come back here, look at our inequality symbol. Where it's less than or equal to, we want solid line. I'll try that one more time. Solid line. And once again, because it's less than, we want everywhere below it. So I'm going to shade everywhere down. There we go. Now, this one right here, our x is greater than or equal to 0. Remember, we said it would be a horizontal. Oh, I'm sorry. So that wrong. This one's going to be the vertical line because our x-axis is horizontal, so we have to cut it in 2. So we have to make a vertical line here at 0. And it's greater than, so it wants everywhere to the right. So I'm just going to kind of draw a little baby arrow to the right. And our last one is y is greater than or equal to 0. This one's going to be the horizontal line because we have to cut the y-axis in half. So go to 0, make a horizontal line here, and where it's greater than, we want everywhere up. So once again, draw a little baby arrow up. And now, we have to figure out where all 4 of these inequalities share a solution region. So I'm going to zoom in just a little bit because this graph is really small. Okay, so if you look here, we want to find where we have everywhere below the green line and the blue line. So below the green, below the blue, to the right of the purple, and above the red, and it's this itty bitty shape right here. So itty bitty shape. There we go. 4 sides. Just kind of shade it in real dark here. Follow it down. There we go. So now that we have our constraints graphed, we're now going to have to find our vertices to figure out if it's going to be our maximum or minimum value for our feasible region. So we have to first find those vertices. So let's see here. we have one 0, 0. I told you before that's always the first and easiest one to find, so let's zoom out a little bit. So vertices will be 0, 0. Then our next one right here looks like it's at 0, 1. If you realize it's always going to be like your smaller y-intercept there. Now this one's going to be a little bit harder to see, so let's zoom back in and see that graph a little bit better. So it looks like this one right here is almost at like 1/2. So 1/2 and 1. There we go. 1/2, 1. Then our last one, going back up here, that way we can see it, is that right there. If you can tell, if that's 2, that means this one right here is on this line, is at 1. So it'll be 1, 0. So itty bitty graph. Alrighty. Now we'll go back, and it tells us that we want to find the maximum value for p equals 3x plus y. Erase all these little stray marks here. So the maximum, what we're going to have to do first is realize that this is our x value, this is our y, and plug them in. So p equals 3 times x is 0 plus y is 0. So 3 times 0 is 0, 0 plus 0 is 0, and we're good. Next one is p equals 3 times x is 0 plus y is 1. 3 times 0 is 0, and then plus 1 is 1. P equals 3 times 1/2 plus, now that I look a little bit closer, it's just barely below your 1, so I may change this one real quick to like 0.75, sorry, 3/4, because it's not all the way quite to 1, it's just really close to it. So we'll put here 3 times 1/2 x, and then plus 3/4. Oh, wrong color, I wanted purple. There we go. So 3 times 1/2 is 1.5. Alright, now 1.5 plus 3/4 is going to give us 2.25. And now our last one is going to be p equals 3 times our x value is 1 plus our y value is 0 equals, now 3 times 1 is 3. 3 plus 0 is still 3. There we go. If we come back up here, we were asked once again for the maximum. So the maximum is the biggest value. So if we look down here, our biggest value is 3. So we say we have a max is 3 at, and our vertice there is 1, 0. And we're all good. That's a linear programming problem for us. It's at practice problem 12 from our work on Monday. So take a second, look over it, see how your work compares, and if you have any questions, let me know. Thank you.